Hi guys, today we are going to study about the technique to solve the Newton's laws problem. So for that, we are going to solve a question. This question has came in October 2021 International A-level exam, and we are going to talk about it. We are going to apply the technique that we know. So in this question, what we are having a sledge, and this sledge is placed on a horizontal on a frictionless slope, and the angle of the slope is 6.9 degree. And in the first case they're asking about the free body diagram, and in the second case they're asking about the acceleration of this sledge. So let's apply the technique. So the step one would be to see the acceleration of the body, and we have to see the accelerations of all the bodies in the system, and we are also have to show it on the diagram. So here in this case, the sledge is going to move downwards. So we are going to draw the acceleration like this. So this is the acceleration of the sledge. Step 2, decide the system. Now we have to take a body and we will call that body our system. Now in this case, we can see that only sledge is the body which is present here, which is moving. So we will say that the sledge is our system. Now we will talk about the step 3. In the step 3, we identify the forces that are acting on the body. Now in this case, as you can see the sledge, which is also our system. So we will find out what are the forces that are acting on the sledge. So the first force is the force of gravity, which is acting vertically downward, and another force is the normal force, which is acting perpendicular to the surface. Now you see this is the answer of the A part of the question, in which they were talking about the free body diagram, and this is our free body diagram. Now to solve the next part of the question, which is to find out the acceleration of the body, we are going to uh, apply other steps. Now the step 4. In the step 4, what we do, we identify the x and the y axis. So what we are going to do, we are going to take the direction of acceleration as our x-axis. So here in this case, as the body is moving in this particular direction, so we are going to take this direction as our x-axis, and the direction perpendicular to it will be taken as our y-axis. Now, after deciding the axis, we can also see that the force of gravity is making the same angle 6.9 degree with the y-axis. Now, the next step. In the step 5, what we do, we resolve the force which is not present on the x or the y-axis along the x and y-axis. So we are going to resolve the force of gravity. So on the x-axis, the component will be Fg sine 6.9 degree, and on the y-axis, the component is Fg cos 6.9 degree. Now you can see that all the forces are lying either on the x-axis or on the y-axis. Now we will apply the step 6. In the step 6, we will apply the Newton's second law along each axis and obtain the equation. So let's apply Newton's second law for the x-axis. The first step would be to find the F net. So we will find out the net force acting on it. Now we can see that there is just one force, Fg sine 6.9 degree on the x-axis, and this is acting along the positive direction. So F net would be Fg sine 60. Now we will apply Newton's second law and we will write F net as ma. So we got ma equals to the force of gravity is mg, ma equals to mg sine 60. We can cancel and we will get the acceleration of the body as g sine 6.9 degree, and so sorry, this is 6.9 degree, and g sine 6.9 degree is actually 1.2 meter per second square, which can be also termed as 1 meter per second square. Now this is our answer. So now in this was a simple question, so that's why we were able to do it just in step 6. But in many cases, you will need there will be more variables in the equation. So you will do what? You will form more equations. Okay, you will form more equations, and by applying the same technique, and you will keep on forming the equation until the number of variables becomes equal to the number of equations. And when the number of variables and the number of equations become same, you can start solving it, and after solving you will get your answer. Here you should remember that in this case you are going to get one, 1 mark for this question, for this part. You will get 1 mark for identify the x and the y axis correctly. Then you will get 1 mark for resolving the forces, and you will get 1 mark for applying Newton's second law correctly and getting the right answer. So in this way, you will be getting marks in your exam. So that's all for this technique. Thank you.